Now we want to talk about the modern data warehouse, and with that we are now choosing between cloud versus on-premise. So on-premise, of course, is the more traditional data warehouse, but nowadays there's also the cloud data warehouses. And in this lecture we therefore want to understand what are actually the differences between them. So we want to understand both of them, and then afterwards we want to understand which one is the best choice for us. And let's start with the on-premise data warehouse, which is the more traditional data warehouse, because in that we use our own local hardware in a usually physically available data center that belongs to the company. And this means that we need to manage everything on our own. We have our own storage layer, so we need some disk space. We also need to have compute resources, so a compute layer. And then on top of that, the last layer is that all of that also needs to be, of course, managed by operating systems, by analytical systems. And with that, we have our data warehouse. And you can see that this is a lot of work, and this all needs to be maintained in our physically available data center. On the other side, we have now this new cloud data warehouses where we don't own any of the infrastructure, but we just use software as a service. This means that we are not owning the infrastructure, but we are just paying for using the infrastructure. And one benefit is that this is fully managed. So we don't need to install anything, we don't need to update anything, don't worry about any of the administrational works, but this was just fully managed. And on top of that, it's also usually more optimized for our scalable analytical needs, because the on-premise data warehouse is usually also a data center that is used for other purposes, and we then are not so much optimized with these new technologies that are optimized for analytical needs. So with that being said, we now want to have a look at both the benefits and the challenges that we can get with on-premise and the cloud data warehouse. And this we then want to use to answer the question, which one of those is the best choice for our company? And we again want to, of course, start with the benefits and then have a look also at the problems. Now that we've understood the differences between cloud and on-premise, we want to understand and find out which one is the right for us and look, of course, at the benefits and problems of those two options. So the on-premise database, one of the big benefits that companies are mentioning is that they have full control. They own all of the data infrastructure. They can decide to add additional resources and how they manage this. And this is usually also helping them in fulfilling some of the data governance regulations or compliance regulations, or at least it is easier for them, or they think it's easier for them because they are used to and they just know, for example, where is the data stored. But usually also in the cloud it is possible to fulfill all of these regulations. The problem on the other side with the on-premise data warehouse is what is the other side of the full control, which is the full responsibility. Because now we are completely responsible for everything. That the data warehouse is available, so that it is secure, that it is updated. We need to buy the infrastructure if we have a need for a larger amount of workload, then all of that needs to be maintained and administrated by the company itself. And with that, there are also usually a lot more costs involved. This includes the upfront costs and also the maintaining costs, because we of course need to update this, we need to administrate this, we need to have employees that are managing that, and of course we cannot use the hardware forever, so we also need to, if something breaks or if there's some new technology needed, we also need to get new infrastructure and new hardware as well. And it is also much less flexible, because what if the workload is suddenly decreasing because we have not so much workload anymore? Then we can not just easily sell all of this hardware very easily. So this is much less flexible. And on the other side, with the cloud, this is fully managed. So we have, of course, a little bit less control, but we, of course, on the other side, have now delegated some of the responsibilities, because the cloud provider is taking care about all of the things. And one of the most important things that companies opt for the cloud is because now it is scalable. This means if the company is growing and with that the workload is growing, we can easily just opt for additional subscriptions, additional resources, and in some cases this can be even done automatically. This means when the workload is increasing, automatically there will be additional resources applied, and with that also the performance can be on a constant level. So this is also not so easily possible with the on-premise data warehouse. And as we've already mentioned, the cloud providers are working on such a big scale that local data warehouses and local companies usually cannot achieve such a cost efficiency. And with that, in reality, the cloud data warehouse and the cloud providers are usually a lot more cost efficient and cheaper than our local data warehouse. And also on top of that, we have many additional benefits. Security is managed, and in reality, again, the security is usually better on the cloud data warehouse. Also, the reliability, we have service level agreements that we have an uptime of 99.9 or in other cases 99.99%, and all of that is guaranteed with the cloud providers. And the last benefit is that, of course, it is also much faster for us. So if we need to implement something quickly, we don't need to order new hardware, install all of that hardware, but we can just immediately use it, even if we are a small company. So we can immediately start and have a quick time to market. So this is one of the main benefits, of course, with these cloud providers. And of course, the regulations can be sometimes a little bit more difficult to fulfill if there is some really special needs for that. But even with that, there are also usually some solutions for that. And now with all of these benefits and downsides, what is our conclusion? So which one should we choose? And nowadays we have to say that most companies nowadays using cloud data warehouses because of all of these benefits that we've seen. It's much more cost efficient, it's much more reliable and much more secure, and of course more scalable. So in most cases nowadays the cloud data warehouse is the better choice. And those cloud data warehouses are also, as we've mentioned, using more modern technologies. For example, they use columnar storage and so-called massive parallel processing. And these are new modern technologies that we are also now want to have a look at to understand those modern developments. So that's what we are doing in the next lecture. We all know that the amount of data is increasing and increasing in the companies. And also there are more and more users that need to process this data. And with that, the challenge and the requirements for our database system and our query performance are increasing as well. And one of the most important modern technologies that is used to combat these challenges is so-called massive parallel processing, or abbreviated MPP. And in this lecture, we want to understand what this modern technology is, how it works, and how we can benefit from that. So to understand that, we want to have a look at a simple example. Let's assume we have some table and we want to get this table returned. So we just run a query against our database system, and then this is basically a task that needs to be processed by the database. So this is the traditional way. We have this task, and this task consists usually of multiple subtasks. And in the traditional way, this will be processed all in a sequential order. So in this case, we need to wait until we get the result for all of these single individual tasks to be executed, and then just in the end, we get our result. But now with the massive parallel processing, all of these subtasks can be processed in parallel. And with that, we don't need to wait until all of the individual tasks are completed, but they can be all started at the same time. And with that, we have, of course, a much better query performance. So the query will be returned much faster. And those nodes, they work independently. It is possible in a so-called shared disk architecture that still we have one external disk, so where the data is stored, and this is just one central location still. And then just the task will be broken down into the subtasks, and just the compute resources are now not shared, but they are completely independent to process all of these subtasks in parallel. But aside to that, we also have the so-called shared nothing architecture. In that architecture, not only the compute resources are completely individual, but also the data storage is now also distributed to multiple data storage layers. So this can be, for example, as 3 buckets, and then in one location we have one data row, and in another location we have now another row. So they can be spread out across multiple storages. And all of those storages now also work independently. They all have their own compute resource, they all have their own operating system, and we call them one node. So they don't share anything. They don't share the storage, and they don't share the compute resources. So they work completely independently. So you can think of them as an individual computer, for example. And this is now, of course, very efficient, because with that, the workload can be split up very effectively and being processed individually. And of course, between those nodes, we have a high-speed connection, so that, of course, all of those nodes can work on parallel, but of course, they work on the same task. So we need to have a connection between them. And with these individual nodes, we can now benefit a lot, because all of that work is processed in parallel. So this massive parallel processing is now a very modern technology and an answer to solving those performance issues that come with large amounts of data. So with that, we can now process millions of rows much faster, because we run those tasks all in parallel. And also, if we have many users that all need to wait until the queries are returned, we can now also process them in parallel, which will also ensure a good query performance, even if we have many people running queries against our database system. And with that, we have now a solution that is helping us with centralizing massive amounts of data, where many users need to also query from this data. So this is a very important technology that is used nowadays by many cloud data warehouse providers, such as, for example, Snowflake. So this is one of the important modern technologies that is used to ensure a high query performance. A second one is so-called columnar data storage. This is also a technology that is optimized for our data warehouse. And what that means and how we can benefit from that, we now want to have a look at in the next lecture. We've already learned in a previous lecture that if we have a very nice looking table with columns and rows, internally the data is stored in blocks, and it's stored row-based. So in one block there is one row. So we have, for example, in this case, the first column value. Then we have in the second one, we have this value of the second column. And this is now, of course, efficient if we need to work on a transactional basis, because then we need to, of course, update all of the columns in one row. But if we now want to retrieve the data and use it for analytical purposes, we usually have queries where we only need to process one or a few columns. And with that, we now, if we use the same way of storing the data, we now need to scan again through all of the different rows to get the result. And now also all of them have to be sent to the memory and have to be processed. And with that, the amount of data, even if we just want to query a subset of it, is way too much, and this is really not efficient for us. As mentioned, of course, this is very good if we have transactional data processing, where we, with one data entry, just need to enter values for all of the columns for one single transaction. So for this transactional data processing, it is very efficient, but for data retrieval, especially fast data retrieval, this is really not the best way. And this is why we have also so-called columnar storage that is now optimized for fast query performance when we want to retrieve the data. Because now the data is again stored in these individual blocks, but now in these blocks, the data is not stored row-based, but we have now in these blocks columns stored. So here, for example, in the first one, we have the column transaction ID, in the second one, the product ID, and so on. So this means if we now want to execute this select command with one column, we just need to get this single block, and we don't need to scan through all of that data and send all of that data to memory and process a lot of data. But we can just go with this single block in here. And now with the lower amount of data, it can be processed also much more efficiently and much faster. And on top of that, an additional benefit is that now that we have the data stored column-wise, the data type that is stored in one block is also just the same. So we have only one data type, and this makes it possible to also compress the data much more efficiently, because we can choose a sufficient encoding that is specifically good for one data type, and with that again the storage needed is less, and again the processing is faster with that. So this is an additional benefit. And this means now in practice that if we have, for example, a table with, let's say, 100 columns, but we only want to query 5 of them, so this is, of course, much more common if we want to analyze the data to see in one moment only a few columns, then we don't need to process all of those 100 columns, but only 5% of them. And with that, we have, of course, now much less data that needs to be processed, and this is now much faster and much more efficient if we want to improve our analytical query performance. That's why in the modern data warehouses, especially in the cloud data warehouses, they use these columnar databases. And nowadays, this is also a very important factor in terms of our query performance.